All right, hey, this is Mr. Almack. We're going to talk about solving rational inequalities algebraically this time. This is section 5.4 in our book. All right, so let's go ahead and get started. So below here we have an inequality, a rational inequality, and we want to know where is this greater than or equal to 0. So graphically what we did is we looked where's the graph above the x-axis if it was a greater than 0. But when we're solving an inequality, we're going to need to do the same process, but we're going to be doing it using some sort of analysis. And so in general, what we need to do is we take our rational expression. Since I know I want this to be greater than or equal to 0, that means I want to know where is this expression positive. So to do that, I need to start by finding my critical values. All right, and so critical values are found two ways. So if it equals 0, this is going to make our lives very easy. All we do is we take all of the factors in the denominator, set them equal to 0. So we have x equals 0, x minus 6 equals 0, and solve. And because it equals 0, we're also going to set all values in the numerator equal to 0. And so in this case, we're going to have 3 individual critical values. So we have x equals 0, we have x equals 6, and we also have x equals 4. So we have these 3 critical values. Then we're going to draw these critical values on a number line. All right, and so our number line needs to have 3 values. In this case, we have 0, 4, and 6. We write them in the appropriate order. And then what we need to do is take our original function, so our x minus 4 over x times x minus 6, and we need to find where is this function positive and where is it negative and on which intervals between 0, 4, and 6. A little bit before that. So notice that 2 of these came from the denominator. So our 0 and our 6 came from the denominator. These values are not actually part of the graph. These are where we would have asymptotes. So what I like to do is at 0 and at 6, these are asymptotes. We are never allowed to be equal to either of these values since these values don't exist on our graph. At 4, however, this is where the graph is actually equal to 0. So we set the numerator equal to 0, that's where the graph is going to be equal 0. So because in this particular problem I have a greater than or equal to, I am concerned on whether a value is equal 0. And I know 4 is equal to 0 for this particular function. So now let's take a value to the left of 0, so like a negative value, negative 5. So if I plug in negative 5, this will be negative, negative, negative. 3 negatives make a negative. So this value is negative. If I take a value here, let's say 2, that would be negative, positive, negative. 2 negatives and a positive make a positive. If I take 5, that would be positive, positive, negative. That would be a negative value. If I take a value over here like 100 or something, this will be a positive value, a positive value, and a positive value. 3 positive values multiplied and divided together will give us a positive. And so once we have this, we need to figure out what is our solution wanting from us. So our solution wants, where is this graph greater than 0? Greater than or equal to 0. So in other words, where is it positive? So it's positive from here to here, and it's also positive from here onwards. And so we're going to write that answer as an interval. And so in this case, we have from 0 to 4, and also from 6 to infinity. All right. So we need to determine where are we going to have parentheses and where are we going to have brackets? So an infinity is always a parentheses. Because 0 and 6 come from the denominator's critical values, those are also going to be parentheses. And then 4 is the only one that has an option to be in parentheses or a bracket. In this case, because we are in particular looking for a greater than or equal to, and 4 equals 0, we are going to use a bracket. And so this is our answer for this particular problem. Alright, for our next problem, again we're going to look to solve this inequality. If I have x plus 3 over x squared minus 1 is greater than 0, we're going to do the same type of thing. We're going to first find our critical values. After we find our critical values, then we'll use our number line. So in this case we have our denominator, so x squared minus 1 is not allowed to be 0, and then our numerator, x plus 3 equals 0. So whenever we're talking about the domain, we use a not equals to sign, but I guess since we're talking about critical values, we can just call it an equal to. So on this first one, I'm going to factor this out. So I'm going to have x minus 1, x plus 1, because it's a difference of two squares. Those equal 0, x plus 3 equals 0. And so that means x minus 1 is equal to 0, x plus 1 equals 0. So we get two critical values, x is 1, x is negative 1. For the numerator, we're going to get subtracting 3, x equals negative 3. So now we're split into two different categories. We have our numerator and we have our denominator. So since these are both on this side denominator, these values do not exist on our graph, whereas this negative 3 does in fact exist on the graph. So let's go ahead, let's draw our number line. So for our number line, we have three critical values. We have the furthest to the left is negative 3, then we have negative 1, and then furthest to the right is 1. Remember, negative 1 and 1 are not actually part of this graph, so these are where asymptotes would be if we were looking at it on a graph. And at negative 3, this is where the graph is actually equal to 0. So now we need to do an analysis. So we have, I'm going to write out the factored form. So we have x plus 3 in the numerator. We have x minus 1, x plus 1 in the denominator. And then we just pick values from each section, each of the four regions, and we're going to see, is this going to give us a positive value for our interval or a negative value? Alright, so if I picked, let's say, negative 5. Negative 5, that would make this negative, and this negative. If all three are negative, it's negative. If I pick negative 2, that would make this positive, negative, negative. Just going to give us a positive. If I picked 0, that would be positive, negative, positive. So one negative and two positives is a negative. And then if I pick something over here like 4, that would be positive, 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 which gives us positive. And so whenever we are graphing this or we're looking at this, we need to then go back to the original problem and see, what do I want to know? I want to know, where is my graph less than 0? Or in other words, where is it negative? And so when I'm looking at this, it is negative on this interval here, and also on this interval from negative 1 to 1. And so when we write our answer, I know that it is going to be less than 0 from negative infinity up to negative 3, and then also from negative 1 to 1. And then we need to look at our sign. So parentheses will go with the infinity every time. Because negative 1 and 1 are both from the denominator, those have to be parentheses. And the only one we really need to worry about is the negative 3. So since our symbol is just a regular less than, that means it didn't really even matter. That's where our function equals 0. but I don't care if it equals 0. I want to know where is it less than 0, so 3 is not part of our solution, so that is also a parentheses. So we have our answer here, negative infinity to negative 3, union with negative 1 to 1. For our third and final inequality that we're solving, you'll notice this one's a little bit different because there's not a 0 on the right-hand side of the equation. So to do this one, we're going to have a slightly different path, but in general, it's the same type of situation. So we still need to find our critical values. The only difference here is the way we're going to find the critical values. So always we still want to have our denominator. Find where does the denominator equal 0. And so when we find that, we just have x equals negative 3. We found one of our critical values. Because the right-hand side does not equal 0, the way we find the critical values for the numerator are going to be slightly different. What we're going to do is we are going to replace the inequality with an equal sign, and we're just going to solve this as if it was a regular equation. So we would start off by cross multiplying. So I'm going to multiply the x plus 3 times 3 to get rid of this out of the denominator. And so we'll get 4x minus 2 equals x plus 3 times 3 would be 3x plus 9. And then we're going to balance the equation. We'll subtract 3x from both sides, and that will leave an x over here. We will also add 2 to both sides. So if I add 2 here, it'll cancel that out. Add 2 here, we get 11. So in this case, on this particular problem, I ended up with a critical value of negative 3 and a critical value of 11. From here, we do what we've done before, go to our number line. And so we have, let's see, negative 3 and 11 here on our number line. So whenever we're going to test these values, this time we're going to do a little bit different process. And the reason is because we aren't just seeing where the graph is positive or negative. We're trying to see where is it less than 3. So just being positive doesn't mean that we're less than 3. You can still have values that are less than 3 and being positive. So what we're going to do instead is we're going to pick values here, plug them into the original equation. We're going to see which one makes this true, which one makes this false. So let's plug in from the first section, like a negative 4. So if I plug in negative 4, I would have, let's just write this out, 4x minus 2 over x plus 3. So if I plug in a negative 4 here, that would be negative 16 minus 2 is negative 18. Negative 18 over negative 1, which is 18. And 18 is less than 3 is what the statement will be. Well, that is a false statement. So that means this is not part of our solution. Now let's pick a number in the center. If I pick 0, I would have 0 minus 2 is negative 2. Negative 2 over 3 is 3, negative 2/3. And is negative 2/3 less than 3? Yes, it is. So that's going to be true. And then finally, let's pick a number over here, like 12. So if I pick 12 and I plug it in, so 12 times 4 is 48, minus 2 is 46. 46 over 15. So this value is a little bit bigger than 3, but we're trying to see, is that value less than 3? So this value is not less than 3, so this is false. On this problem, we only have one interval, so we're going to write our solution here. Again, this came from a denominator, so this value cannot be equaled. It's going to create an asymptote, but it doesn't really matter since we don't have an equal sign here anyway. So when we write our solution, we will have negative 3 up until 11. We cannot include the 3 because it's an asymptote. We cannot include 11 because we want to know where is it strictly less than 3.